Okay, boys. Here. Let's start now.
Sir, I have a question before we start.
Yes.
What is the grade boundary for compared to last year or approximately?
Usually 32, 31 is there.
31.
32, 33. Okay, in this question, an experiment was done to determine the formula for hydrocarbon CX and HY. So we have CX and HY. 10 cm cube of this hydrocarbon was burned in excess of oxygen. So we burn in the presence of oxygen. When complete combustion is there, the complete combustion of the product, a complete combustion of a hydrocarbon will give a carbon dioxide plus water. Okay. So they mention here 10 cm cube of a gaseous hydrocarbon. So how much is a gaseous hydrocarbon? 10 cm cube. When it was burned in excess, it formed 20 cm cube of a carbon dioxide. So 20 cm cube of a carbon dioxide is formed and 30 cm cube of water vapors. Remember one thing, the ratio of the volume is always same as the ratio of the moles for gases. Ratio of the volume of a gas is same as ratio of the moles of the gas. So what is the ratio between 10, 20 and 30? So when I take a simplest ratio, I'll divide all of them by 10. So when I divide this by 10, so this will be 1 here, this will be 2 here, and this will be 3 here. So as you can see, how many carbon atoms do you see on the right hand side? 2. Like 2 molecules of carbon dioxide. So it means it should have 2 carbon atoms. And how many molecules of water are produced? 3 molecules of water. Or how many hydrogen are there? 6 hydrogen. So the formula is C2H6. So C should be the right answer. So whenever we have a hydrocarbon and we burn, and we know the volume of the gases which are released, so we can take a simplest ratio between the volume of the gas. So yeah, I will repeat this. Look. Look, in this compound, we have a hydrocarbon which is having a formula of CX and HY. When we burn completely in the presence of oxygen, what it gives, it will give a carbon dioxide and it will give water. CO2 plus H2O. They mentioned that the volume of the hydrocarbon was 10 cm cube. The volume of a carbon dioxide is 20 cm cube. And the volume of the water vapors, 30 cm cube. And we know the ratio of the moles and the ratio of the volume of a gas is always same. So what is the ratio of the volume of the gases? How to take a ratio? Simplest ratio, I'll divide by the common factor. 10 is common, so I'll divide all of them by 10. When I divide this by 10, so means the ratio of the volume here, this is 1 because 10 divided by 10, 20 divided by 10, this is 2, and 30 divided by 10, this is 3. So what does it mean? It means the ratio of the volume is 1 to 3. So the ratio of the moles should also be 1 to 3. It was written 30. As you can see here, this is 30. This one is 20 and this one is 10. So when I take a ratio of 10, 20 and 30, so what is the simplest ratio of 10, 20 and 30? It is 1, 2 and 3. So we got 1 mole of a hydrocarbon, 2 moles of carbon dioxide and 3 moles of water. So from this, we can identify if 2 moles of a carbon dioxide, so means this hydrocarbon should contain 2 carbon atoms. Because how many moles of carbon dioxide, same number of carbon atoms should be there. And how many 3 moles of water or how many hydrogen will be there? 3 multiplied by 2, 6. So C2H6 will be the formula of this compound, the hydrocarbon. That's how we worked out.
Like empirical formula.
Like empirical, yeah. The question is, which substances can be obtained by cracking hydrocarbons? So when we do cracking, what are the results of a cracking? We can get alkane. We can get alkene. That is one possibility. Or what is the second possibility? For a cracking, we might get alkene or hydrogen. These are the possibilities. So we can get ethene, but we cannot get alcohol. We can get hydrogen, but we cannot get alcohol. We can get alkene and we can also get hydrogen. But the polymers are not formed by the look, ethene can form a polymer, but that is polymerization, but that is not the cracking.
Sir,
In a cracking, we break down and polyethene, a formation of a polyethene is a formation of a long chain compound. But the term cracking means breaking down a long chain compound into a small and the useful one.
sir, when it will bring it.
No, cracking never produces H2O. It will produce either alkene or alkene or hydrogen. Fermentation produces carbon dioxide and alcohol.
But gives H2O.
What?
Which process gives H2O?
Which process gives H2O? Reaction between hydrogen and oxygen. In a fuel cell. It would
Burning.
H2O burning hydrocarbons. If you burn hydrocarbon, it also produces H2O. Two isotopes of the chlorine are there, 35 and 37. State why these two isotopes of a chlorine have the same chemical properties. So they have the same number of valence electrons. No need to mention proton. Whenever a question is about the chemical properties, you will say same number of electron in the last cell. No need to mention a proton. Proton is the identity of the element, but the chemical properties depends on the presence of electrons in the last shell. Last shell. Valency shell, yeah. Last shell, yes. Describe a test for a nitrate ion. How we can test a nitrate ion? We add sodium hydroxide and aluminium powder or aluminium foil and heat. And we test the gas with damp red litmus. It will turn blue. So you have to memorize, as I mentioned, you have to memorize the test for both positive and the negative ions. Here, a copper is there. A copper is the same question. A copper is reacting with oxygen from the air to form a copper oxide. What is the color of the copper oxide? So copper oxide is black in color. Copper as a metal is shiny brown or pink, but copper oxide, which is formed, is not white. It is actually black in color. So you have to memorize the color of the copper oxide. Yeah, result of a nitrate produce ammonia, but the result you don't say it produces ammonia. How you can confirm? Test for a nitrate adding sodium hydroxide and aluminium powder and heat, and the result test the gas given off with a damp red. It will turn blue. That's the test for the gas. Gas is ammonia, which confirms the presence of the nitrate ion. And aqueous sodium hydroxide and aluminium foil were added. So this is also a test for what? This is also a test for nitrate ion. The mixture was warm and the gas given off was tested. First thing in observation, you cannot write ammonia form. This is wrong. Even though ammonia does form, but in observation, you cannot write the name of the compound. Because while looking at the compound, you cannot say this is a compound. So you have to, observation is test with a damp red litmus paper, which will turn blue. Bubbles will be there. Yes, gas is given off, so definitely bubbles. And test the bubbles or the gas which is given off by a damp red litmus paper. Sodium hydroxide, aluminum bubbles, damp red litmus paper turn blue. But don't mention ammonia. Why? Because it's an observation. In observation, you cannot write the name of the compound. This question is about the salt. We have a salt that is insoluble. These type of questions are common one in which you have to write the test, the preparation of an insoluble salt or a soluble. So we want to prepare lead iodide, which is insoluble. So if I want to prepare a lead iodide, and they mentioned you're provided with solid lead nitrate, and we have solid. So first, to prepare a insoluble salt, we need solution. So first what we do, we'll take 2 test tubes filled with equal amount of the water. To the first test tube, we'll add a lead 2 nitrate, the solid, and dissolve. To the second test tube, we'll add a silver iodide, a sodium iodide, and dissolve. And then like this will be now aqueous solution, and this will also be an aqueous solution of a lead nitrate and aqueous solution of a sodium iodide. After having the aqueous solution, we'll mix them together. When we mix them together, what will happen? It will form a precipitate of lead iodide, which is yellow in color. So for
we use the
then how to remove this lead iodide? We'll use filtration. Filter, then because it's a wash, then dry.
methyl orange.
No need for methyl orange. This is preparation of insoluble salt. So for insoluble salt, you have to prepare by mixing the two salt solutions. So first, we'll add water to lead nitrate and sodium iodide to make an aqueous solution. Then what is the equation for precipitation? Because this is the insoluble salt lead iodide. So if I'm forming a lead iodide, what are the ions react? So there is a lead ion and there are two iodide ions, because lead ions, aqueous, iodide ions, when they combine, it will form a lead iodide. Which one?
This brown sprinkles.
Lead iodide, yellow precipitate.
Isn't that used in like
Yeah, but the thing is, color, when you classify, you will say yellow. They ask the use. So add water to lead nitrate and sodium iodide. Then we'll make a solution. Then we will add or mix the two solutions. To form PPT, the precipitate. Which one?
solution.
Then we will filter, wash, and dry. Yeah. Whenever if they ask us to write a chemical equation, we always no, for ionic equation, when it's a precipitation reaction, it's always the ionic equation. Because they ask precipitation, so it's always the ionic equation.
So we write
What you will write?
for the chemical equation. See the question. Point a chemical equation is great. Yeah. So we write NaI plus H2O plus BbI2 is equal to constant, right? That will be the answer. It should include H2O or no?
Which one?
Now he's saying a chemical equation is in. So we write NaI plus H2O.
No,
plus
but which? Why NaI? Like chemical equation.
Sodium iodine plus BbI2
Okay.
plus
If they ask write a chemical equation, yes, you will write like this.
plus
Why H2O?
because this is mixed in water.
No, but water is already. Water is not a reactant here. It will dissolve. No, water will dissolve. So it will, as a result, it will produce lead to iodide plus sodium nitrate. Water is not the reactant. Water is the medium in which they are reacting, the ions. So if you want to write an ionic equation, you cancel out the common ion. Nitrate and sodium will cancel out. So lead iodide gives iodide ion and lead ion. Why don't we break the product into ions? Because the product is solid. The product which is formed is a solid. That's why both sides are no. We only break down a substance into ions which are aqueous. If it's something is solid, liquid, or a gas, we don't break down into ions. If something is solid, liquid, or a gas, we don't break down into ions. Only aqueous break down into ions. when we are writing an ionic equation. Even a liquid, like example, if there was an equation calcium is reacting with a hydrochloric acid to give calcium chloride plus hydrogen. Okay. And they ask us to write an equation. If they ask us to write an equation, ionic equation for this, what is the state of a calcium? Calcium is solid, hydrochloric acid is aqueous, calcium chloride, most chlorides are soluble, and hydrogen is a gas. So calcium is solid, I will not break down calcium into ion, it will remain as it is. Hydrogen is a gas, I will not break down into ions. So only aqueous will break down into ions and the common will cancel out. So chloride will cancel out with chloride. So this will have two hydrogen ions and there will be one calcium ion. So solid, liquid and a gas, we don't break them into ions. Only aqueous will break down into ions.
Solid, liquid and a gas.
Will not break down into ions. Only aqueous will break down into ions.
What's a liquid or two different?
Yes, aqueous means dissolve in water. Liquid is a state. Like example, you can have anything in a liquid state. But if something dissolve in water, it's called aqueous. Aqueous substances break down into wine. This is a displacement ionic equation. Just aside, what did chemistry course last? The changes were in the course were mainly in the organic chemistry part plus the test for this one, sulfur dioxide contact process. What is the doubt here in this one? Student has sent me, what is the doubt in this one?
So it's not A or B because it's true, so it will be C of
On the next page. But the next page is not related to that graph. Huh?
sending it short. 1 second.
Experiment is repeated using a solid Z impure. Sample of a, so suggests the difference, if any, on the melting and the boiling point. What will happen to the melting point?
Melting point will
Decrease and the boiling point.
increase.
So the substance melting point, if it's impure substance, the melting point will decrease. And what will happen to the boiling point? It will increase. Now a sample of a pure Z was allowed to cool from 120 to 20 degrees. The total time it was 8 minutes. Starting point is X. Sketch on the grid how the temperature of a sample of a pure Z changes from 0 minutes to 8 minutes. So how the temperature changes from, you have to check. See in this one, this is 120 and you want to cool it till 20. And the graph shows the melting point. So this is a solid. Here you have a solid and a liquid, and you have a liquid. Liquid is turning into a gas. So you're cooling it from 120 to 20 degrees. So you want to sketch a graph, the cooling curve you want to sketch. So at 80, what will happen? It will cool like the liquid turning to a solid to the freezing point, and the temperature does not change. And
That's wrong.
no, this is not correct. Not straight line. No, it should not be straight line. Because no, not about curve. It's a cooling curve. So starting from 120 till 80, because at 80 the liquid is turning into a gas, liquid is turning into a solid, so it should freeze. And then, because as you can see, we start from here, then a liquid is turning into a solid. So if a liquid is turning into a solid, the temperature does not change. And then it will continue until it reaches 20 degrees. So this is what we need. Yeah, they mention here the total time take was 8 minutes and it cooled from 120 to 20. So when it cooled from 120 to 80, it will start to freeze. So when it is freezing, the temperature does not change. But once it all freezes, then the temperature start to decrease and eventually it will reach 20.
Can we just give it a horizontal?
Which one?
Horizontal.
But we need only for 8 minutes. We want to sketch a graph. You cannot draw a straight, like if you draw a straight line like this will be considered as wrong. Why this is considered as wrong? Because we know the temperature, the melting temperature of this compound, the melting point of the compound is 80 degrees. So if melting point is 80, the freezing should also be 80. Like at 80, it will freeze. So once it reaches 80, it will freeze. So you will not have a straight line. So this won't be a straight line with a constant gradient. So first what will happen, it from 120 it will reach 80, then it will start to freeze, and then because of the previous graph, yeah, the substance, and then it is 120. We just have to sketch, it's of 2 marks. How do we know that this is a sketching? They did not say if this is sketching, not exact numbers. They did not say for how long it was freezing. Part D. Describe how the motion of a particle of a pure Z changes from 0 to 2 minutes. Look, from 0 to 2 minutes, the temperature was increasing. If something changes the temperature, so the particle will move faster or vibrate at a higher speed. If they ask, they explain the motion of the particle from 2 minutes to 5 minutes, so then what you will say? The particle move away from each other.
Vibrates as a temperature.
No, that when the state is changing, particles move away, solid turn into liquid. But you don't say the speed changes the kinetic energy.
So
Here,
one note for writing more vibrations and one note for writing that when the temperature is increasing.
yeah, that because from the graph, from 0 to 2 minutes, the temperature is increasing. So when the temperature is increasing, the particle will vibrate faster. But I'm saying if they ask the same question, what happened from 2 minutes to 5 minutes? So you will say the temperature does not change. The particle move away from each other, only the state changes. Energy is used to break the bonds. It's fine, like just particle move faster because the temperature is increasing. Because from 0 to 2 minutes, they did not specify here in the question that any change in temperature. You have to check from the graph. From the graph, you will say temperature increase, so the vibration will also increase. Is it fine to say volume increases as the constant pressure as the state changes? When they ask about the particle, you just have to explain the motion of the particle rather than the overall state. You don't have to say anything about the volume. State uses a same size container. A student does experiment to show the hydrochloric acid is a strong acid and ethanoic acid is a weak acid. The student add an excess of a hydrochloric acid and excess of ethanoic acid in a large lump of calcium carbonate. Only identity of the acid is changed between the experiment, all other conditions kept same. To observation, whenever a carbonate is added to acid, we'll observe fizz and the solid will dissolve, the metal carbonate will dissolve. So the student uses the same size container to check the pressure and that the pressure is same for each experiment. So what other things we should state? 3 other conditions that must be ensure a fair test. So I should take you take the same concentration of the 2 acids,
And the same volume of the 2 acids.
same volume of the 2 acids, same temperature of the 2 acids, same size of the lumps, same mass of the calcium carbonate for the both experiments. Like even though it is excess, but like if I use like 10 gram of excess here, 10 gram of excess here. So I should use same temperature, same mass, same size, and same concentration of the two acids. No, 10 gram of the calcium carbonate we should use for both of them, like if it is in excess. The flame test, how to carry out a flame test? Describe how you carry out the flame test on the salt. So what we do, we take a nichrome wire dipped in concentrated HCl and place it on the hottest part of the flame. We'll take a nichrome wire dipped in a nickel chromium alloy. Nickel chromium alloy. Nickel is an metal, chromium is also a metal. So you have to memorize. This is a test to check the presence of positive ions, the cations, flame test. We take a nickel chromium wire dipped in concentrated HCl and we place it on the hottest part of the flame. This I will show that. Yeah, that is also good. Flame test, I remember last time also I did that. So if you want to test, like we have, this is a Bunsen burner is there, and we have a variety of ions which we can test.
In the previous question,
So this is a nichrome wire, which is dipped in a concentrated HCl. 5 mole per dm cube is a very high concentration. This is to clean that. Okay. And then we take a sample. Any other impurities are there will be removed. Then we take a sample, and if a sodium is there, it will give a sodium yellow. Your colors in the lab are different from real colors actually. Because like resemblance is there. Potassium is there, lilac. You will observe a lilac. Yeah, violet or purple color. And if it is lithium, brick red or a red color, so we place on the hottest part of the flame. Then we have a calcium. Calcium is brick red. Calcium is also red. Orange red. Barium apple green. Then we have copper is there, green or blue. Nichrome wire. Yeah. Okay. Yes, because like unreactive metal you need. Why we place the sample is taken, like we took a sample, like different flame colors because of these fireworks, like it produce a different characteristic flame because of the presence of different metals are present. That's why different flames are colors are there. Not diffusion, explosion. This is a firecracker explode, and depending on the metal, like example, if it's a giving a green, it means a barium is there. If it is giving a violet, potassium trace is there. So the sample was there on the nichrome wire. They did not show how when it is taken, but the sample was placed on the nichrome wire, and then we burn it. Why we place on the hottest part of the flame? you will learn that idea about electronic transition, not in AS, A2. The transition of the electron, when you put something under a high temperature, the electron jump from one shell to another and they return back and give a characteristic color, characteristic light. That is responsible for the specific color of this. So why we put this on a hottest part of a flame? To cause the electron transition. Yeah, so that when electron jumps to higher shell and return back, it give a characteristic color. This happen for other element, non-transition as well. This can happen for any element. It depends on how much. That's why we need a hottest part of the flame. Why do we do with nichrome wire? Nichrome, because nichrome is inert. You can also use a platinum wire. Inert metal like nichrome, nickel, chromium. It is inert, does not react. Plus, it has a high melting point. What? Yeah, in terms of, but some metals have characteristic color. Yeah. No color, unreactive plus high melting point. Like these are the characteristic we look for. It should not have its own characteristic flame color. It should not react with a substance and it should have a high melting point because we place on the hottest part of a flame, so it might melt. So any other question or doubt? Yeah.
Exas.